Okay, greetings to all. I am Dr. M. Shakti Mohan, Associate Professor. In today's video content, we are going to discuss about the tutorial problems and solutions regarding multiplexer, demultiplexer, encoder, and decoder. Okay, so in the previous content, we have discussed about the concept of MUX, DEMUX, encoder, decoder. That is the theoretical part and the design part. And in this video, we are going to discuss about the problem solving in the multiplexer, demultiplexer, encoder, and decoder. That is how to simplify the problems by using MUX, DMUX, encoder and decoder. We'll get into the video. I hope you can see the content video. Okay. So first we are going to discuss about the multiplexer kind of problems. Okay. So the first problem is design a 16:1 multiplexer using two 8:1 multiplexer. Okay. So that means it is a very simplified problem only. You can see. So it is a diagrammatic problem. Okay. So you can see first you have to draw the two 8:1 multiplexer, and as it is you have to mention the inputs. Okay. So 8:1 multiplexer. So there are three select line will be there and 8 input will be there and one output will be there. First you have to draw the skeleton of the circuit, and after that with the help of one OR gate just to connect the two outputs. Okay, so there are two 8:1 multiplexers. No. Okay, so those two output will be connected with the help of an OR gate. Okay, so you see here I'm just mentioning here. Okay, and so this is how you have to design the multiplexer problem. Okay, so the next problem is 16:1 multiplexer using 4:1 multiplexer. Okay, so that means so 4:1 multiplexer will be used here for designing the 16:1 multiplexer. You can see here. Okay, and next we'll go to some numerical problems. Okay, so now you can see. Wait, let me open with the PDF annotator so that I annotate also. Sorry for the inconvenience. Just wait for some time, because in the Nitro PDF I can't be able to make the annotations. That is, I can't be able to write it. I hope you can see the content video. Okay. So the next problem is you can see they just mention one boolean function, that is implement the given boolean function using multiplexer. They didn't mention 8:1 multiplexer, 4:1 multiplexer. Likewise, they didn't mention. So simply they just mention multiplexer alone. Okay, so that means according to the input will go. Okay, so according to the input, if the input contains 8:1 multiplexer na, so in the output also will use 8:1 multiplexer as a design. Okay, so otherwise there is one additional step will be there. Okay, so in this problem there is no such specific mentioning. Okay, so in the input they just mention summation 0, 2, 6, 7. Okay, so it is very simple. Since the inputs is from 0 to 7, so that means it we need 8:1 multiplexer design. So first just to draw the skeleton for the 8:1 multiplexer, and after that what are all the input they just to mention it in the sum. You have to connect it with the logic 1. For example, here 0, 2, 6, 7 will be there. No. Okay, 0 will be connected to logic 1, 2 connected logic 1, 6 will be connected to logic 1, and 7 is connected to logic 1, and remaining all other inputs are connected to ground. Okay, that indicates it is logic 0. So the given term is connected to logic 1 and the remaining term is connected to ground. Okay, and since it is a 8:1 multiplexer, we have a 3 select line will be there. Okay, so that's all about the problem, right? Okay, so the next part, it is somewhat different compared to the previous sum. Implement the following Boolean function represented by the help of truth table. Uh, for this truth table, you have to design a multiplexer. Okay, so again, in the previous problem, they just mention a numbers, but here they don't mention the numbers, but there is a way to get the numbers from the truth table. Okay, it is very simple. This is 0 and this is 1, this is 2 and this is 3, 4, 5, 6 and 7, right? Okay, now you can see the y is, okay, so wherever the 1 will be there, you have to take it out. Okay, so it is very simple. Y is equal to summation m, where the y will be there. Here you can see 1 la y will 1 la, sorry, wherever the 1 will be there in y, here you can see 1 la 1 will be there and 2 la 1 will be there. That means 1 comma 2 comma, and after that 4 comma 7, right? So 4 comma 7. So this is what the number. So again, you have to draw the skeleton for the 8:1 multiplexer. So 1, 2, 4 and 7 will be connected to logic 1, and the remaining outputs are all connected to logic 0. Simple, right? You can see 1, 2, 5, sorry, 5 and 7, not 4 and 7. 5 and 7 will be connected here, here to the logic 1, and the remaining will be connected to ground. And 3 select lines, it is a default only, right? Okay, so the next problem, implement the following boolean function using 4:1 multiplexer. So this is what I have already told you. Okay, you can see in the input la, that is in the summation m la, they just mention the inputs from 0 to 7, right? So that means it requires 8:1 mux. Actually this is a 8:1 multiplexer design, but in the sumla they ask us to implement with 4:1 multiplexer. Okay, so that means one more additional step is required to design. Okay, so that also very simple. Okay, okay, and the additional step is implementation table. It is very simple. Just to make a table, that is d0, d1, d2, d3. Okay, once you make a table, okay, so there are two rows you have to add it, that is a bar and a, and after that from 0 to 7 straightly you have to mention. Okay, so don't jump the number like a k map. Okay, so just straightly. Okay, that is 0, 1, 2, 3, 4, 5, 6 and 7. Okay, and after that what are all the inputs given in the sum, you have to round it. Okay, for example 1 is there, so 1 ku round, and 3 round, and 5 you have to make a round, and 6 you have to make a round. Okay, so once you got once you completed the rounding, okay, then you have to make a calculation. That is, you can see in the d naught there is no round. Okay, so that means there is no a bar and there is no a. Okay, since there is no a bar and a, I am just to mention as a 0. Okay, and in the d1 both a bar and a having a round, so that means a bar plus a is equal to 1, no? So that one you have to mention it here. Okay, and in the d2 a there is a round, so that means you have to mention as a, and d3 la a bar round will be there, so I'm just mentioning as a bar. Now you can see the 8 input is converted into 4 inputs, right? So now it is very easy to implement it with the help of 4:1 multiplexer. As you can see, this is what the implementation. It is very simple, no? Right. Okay, and this is one example. In the input they just mention a canonical form, that is unstandard form. But unstandard form you can't able to get the numbers. Okay, without numbers you can't able to design the multiplexer. So first you have to convert this unstandard form, that is canonical form, into standard form with the help of Boolean algebra. Then the numbers will be taken, and after the numbers taken, it is very simple. Okay, you can see, okay, the implementation table and the multiplexing, right? Okay, and this is one more example. In the input they just mention the input with the help of POS. Okay, but we have to mention the ones. Okay, so that means given terms you no need to mention the rounding, and the remaining terms you just mentioning the rounding, and after that make a calculation and do the sum, right? This is what the instruction for the this kind of sum. So this is how we have to design the multiplexer, right? Okay, so let's move into demultiplexer problems. Okay, the same thing will be there. Okay, so next demultiplexer problem. Okay, now you can see implementation of combinational logic using demultiplexer. So in the sum they just mentioned implement the full subtractor using demultiplexer. So this is what the truth table for the full subtractor. You know that from the truth table how to get the numbers, right? So again 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so wherever the 1 will be there, you have to take it out. Okay, so for the difference the 1 will, wherever the 1 is there now, so 1, 2, 4, 7 1 will be there. So this is what the output of difference, right? And for borrow out, this is what the output, that is summation m 1, 2, 3, 7. Okay, now just to make a skeleton of the demultiplexer, since demultiplexer means what? 1 into many. Okay, that is 1 is to n concept. So d in will be there here, and y1, sorry, y0 to y7 you have to mention it here. Okay, so first output d naught la 1, 2, 4 and 7 la you have to make the connection. Okay, so you just to mention one OR gate, and y1 is the first connection, then y2, y4, y7 just to make a connection, and this is for d. And for the same concept la you have to make a B out also with the help of one OR gate, right? So this is how you have to do the demultiplexer kind of problems. Okay. Again, here in this problem, they just to mention the number straightly. Okay, it is very simple, right? So there are two output will be there. That is F1 and F2. So for F1 one OR gate, and for F2 one more OR gate will be there. And wherever the number will be there, so from that you have to make a get a connection and connect it to the OR gate, right? So this is what the implementation diagram. So this is how we have to do the demultiplexer problem. Okay. Next, decoder. So demultiplexer and decoder is more or less same only, right? So more or less same only, not a huge difference. Okay. So in the demultiplexer, select line will be there, but in the decoder, enable line will be there. You can see here. I'm just to show you. Okay, you can see this is the demultiplexer problem. There is a select line. Okay, but here it is a decoder problem. Only the select line is replaced with enable line. That's all. Apart from that, the same procedure will be followed for decoder like D multiplexer, right? So these are the problems. Okay, so very simplified problem only. I hope you understand the today's video content. In today's video content, we have discussed about the multiplexer, demultiplexer, and decoder problems. That is tutorial problems and solutions. It is very easy. Okay, so I hope you understand. Thank you.